Okay. Hi everybody. Hope you're having a good day today. So I'm going to be talking today about consumer-driven contracts, which are kind of part of a touchy subject whenever we're talking about service-oriented architecture, microservices, anything that's now more loosely coupled. And the touchy subject is the integration tests. Where does that fit in our pipeline and how painful that can be? And consumer-driven contracts are a way to alleviate some of these nightmares that integration tests come to surface. So who am I to talk about all this? My name is Pierre. I've been an engineer at Newsweaver for almost 10 years now. So Newsweaver is a company that does software as a service, and we're providing an internal communications platform and a bunch of services as well for large companies to manage their communications to thousands and tens of thousands of employees all across the globe. So companies like Vodafone or British Gas, Rolls-Royce, all these kind of very large global companies that have a need to unify their communications to engage their employees across, well, different campaigns and different content, and obviously measuring the engagement of their employees across a number of different channels, be it emails, intranet, enterprise social networks like Yammer and all that. So over these 10 years, for the most part of 6-7 years, I've worked on a single team where we were all working onto one, what could be characterized as a monolithic application, large app, one code base, J2E, kind of standard stuff, multi-tiered app. And I want to clarify, it's not a legacy application. It's still making for 90% of the revenue of the company, and it's still going great. But it had its problems for obviously deploying and all these kind of things. So 2 years ago, I moved to like 2-3 years ago, I moved to a new team with the emphasis on a new product, which was around analytics. Analytics around the intranet and enterprise social networks. And since it was a new product, it was an opportunity for us to start tackling some of these pain points that basically led us to do continuous delivery. And like, this is not a microservices talk, so I'm not going to be talking about any of this. But microservices is what emerged as the solution for us that was for continuous delivery. We didn't do microservices because it was cool. We did it because it solved our problem. And now most of the work that we do is around microservices. So we went from this side on the left to this on the right. You might be familiar, so what would be on the left would be a monolithic architecture with some components, with some boundaries, if you're lucky. If you're not lucky, then there's no boundaries in there and it's just all spaghetti. But that's kind of the main point is you have a large app under one runtime that's talking to one database. And whenever we're moving to decoupling this sort of app, then we're moving to externalizing all these boundaries that we know and make them actually much clearer, having the data owned by these boundaries. It's not about really the size of this. So like if you're talking about microservices, all these might be very small, but this is kind of standard. Now we're decoupling things and having them in clear boundaries, owning their own data. One thing that this graph does not show, this diagram does not show, is the links between all these parts. On the left side, these interactions are very much implicit. We're under the same runtime. The interactions are just kind of all handled by the compiler for us. It might be an interface, it might be just a method, it might be a field in a class. And altogether, we don't really think about these ones because if we were to change them, the compiler would actually warn us. And usually the compiler doesn't even warn us because when we change them, we refactor them with our IDE and everything just is all nice and green. But when we move to this loosely coupled architecture, when we want to be able to change this thing individually, now the interactions become much more central to the problem. We don't have the compiler warning us now that we've broken a REST endpoint, or that suddenly we're returning the data in a slightly different shape and form, or that we've returned a different, let's say, error code or a different status code or if we've changed the structure of a message over a message queue. All these kind of things now become very much more centric and a lot more brittle because there's almost no validation. Before we didn't even have to think about it. So typically, if we're looking at two services talking to each other, they might be communicating over like standard REST over HTTP. So we might have a GET method that says for a login service that's going to need to know some details about a given user. We're going to get the user by username. talk to that API endpoint, and it's going to respond with kind of typical JSON structure with some details about what we really requested. But now, as I said, this was validated for us before. How do we test all of these things? How do we test that the endpoint is the one that we wanted to? How do we test that the status code that we get back is the one that we expected? And especially, and finally, more importantly, how do we expect that the structure of the data we are getting back is the one that we expect? If we're looking at that in the same runtime, this could just be a method call on an object, and the refactoring, the compiler will catch all that. Now, it's all decoupled. It's nice because we can change things independently, but we can also break them much more easily. So let's see, for example, the team responsible for the user service decides to say, well, actually, we have a different requirement now. A user can have multiple roles. So we're going to change our user object. We're going to refactor it. Now, it's no longer only has one role. It's going to have multiple roles, and we're going to have an array of roles. So the user service team is running their service in production, and obviously they haven't started anything yet, so it's all well and good. And the authentication team, which works on the login, has that running in production, and the login service has been there for probably months and months. It works, nobody's touching it. There's still a team owning it, but it's pretty solid. They're not really touching it, and obviously blissfully unaware that maybe something is coming. It's still running fine. The users team go and implement their changes. They're maybe refactoring their class. They're refactoring their code. They're changing their data model, everything behind it, saying, well, we're happy now. We have our new requirement, multiple roles. Login service, still going along, no problem. And the user service has not been deployed yet, so still no problem. Now, the tests are passing in the build as well, because it's nice. We had all this refactoring tool. Now we're expecting a user to have multiple roles for the user service. We've changed our tests, so our tests are passing. Everything is fine. Login, still no problem. I think you can probably guess where this is going. And now we're going to deploy this in production because we're happy, or our tests are passing. It looks like we're good to go. And well, the user service still works well. Still receiving requests. Maybe if we have monitoring, we still see, well, we're receiving a number of requests. We respond fine. There's no errors. But suddenly now people can't log in anymore. And this is where the scrambling begins, because if this login service was running along for ages, now who's getting the call? Who's getting the blame? If you're lucky enough that you have monitoring and alerting in place, you might have some synthetic monitoring that tells you, well, people can't log in anymore. If you're less lucky, then maybe somebody calls you and say, well, why can't people log in anymore? And now it's like looking at logs, figuring out. And it might actually be some very obscure error of deserialization or something like that that shows up in the logs, in the login, and it's just very, very obscure. So maybe we should have tested something before deploying our service into production, right? But from the point of view of the users team, they've kind of tested something. Well, we have our unit test, and there's no problem. So they go back to the authentication team saying, well, don't you test that you integrate with us? And the authentication team goes, oh yeah, well, we mock your service, but our mock just returns a single role. It doesn't return multiple roles. But you never told us that you changed that. But how would we know? How could we transition? So tested what? And who should be testing it? Who's the responsible party of saying, well, I should test this new thing? At what stage should I test it? And testing is really just there to stop us from doing something stupid. And when we want to test something, we actually want to say, I want to test this, and if it fails, I want to know that this is because this happened. I want to know, I don't want to have to figure out, okay, now I've started my whole system, people can't log in, and I have to figure out why. And we want to know that as early as possible as well. Here, well, that was way too late because it was in production. So the two teams go together and say, well, okay, we're going to have to test some real stuff. Obviously, mocks are not working because we didn't tell you. So whenever we make a change, then maybe we just have to integrate with each other and just make sure that people can log in. So off we go. Maybe those two services are Docker containers. That's easy. We're going to spin those two containers and link them to each other. And then we're going to test that the login works. But we need users to log in. So first thing we need to do is start a database and input a little bit of mock data so that we have a user to log in with and test. So that means now on top of our two containers, we also need to maybe start a, say, Postgres database. So we need to provision that up and start it up. And now okay, let's try and log in. Login service is kind of obscure to test directly because there's a lot of redirects. It's like shibboleth and single sign-on and all these different things. So they decide, actually, we're going to start the front end for this and use a nice Selenium test and just input login password and make sure that it logs in well. Unfortunately, now there's more things because we do IP checking on top of things to make sure that people log in from trusted locations. And this also has data. And it's not Postgres, actually, it's MySQL now. So we also need to start MySQL, create tables, create some data. So, OK, is that it now? You can probably guess now there's a lot of white space here. So maybe there's more things coming up, right? And it goes on and on and on. Now the login needs to generate a token. And it needs certificates. And now we need to provision some certificates. And now this is just turning into a really sad story because all we wanted to test was that small interaction. And now, depending on who was going to be responsible for that entire test, is if it was the user service to say, well, actually, I want to verify that I'm not breaking the login, now they have to be aware of another 4 different services that might change. And if these services change, then that test is going to break. They have no business knowing about all these other things here. They have no business provisioning this data. They have no business generating certificates. And what it's going to do now is we're turning this small interaction into full end-to-end integration test, which means now we need an environment, we need databases, and it's just a big temptation saying, well, no, let's start the whole system and just test that it works. And obviously here, there's only, let's say, 6 services. What if you have 50? What if you have 100? So let's try and test something smaller and earlier, and this is where the contracts are coming in. Now let's zoom back into what we really wanted to test was that call from the login service to the user service. So these 2 teams now, well, they're going to have to talk to each other. That's what they wanted to do. They wanted to say, well, when you make a change, I want to know. They're going to come together, and they're going to agree on a contract saying, this is the way you interact with me. This is the way I respond to you when you actually send me this kind of request. And I want to stress this is not API documentation. This is not something that's going to go on a wiki that it's going to drift off and that we're going to say, well, actually, you're not using the API the way you're supposed to. Look into Confluence. It was written there. Or actually, you forgot to update the wiki. And like we kind of all know that the kind of problem that can arise from that. The main point here is that this contract is going to be there for the consumer side, which is going to be the authentication team, to ensure that they are indeed interacting with the user service the way it's in the contract. And on the other end, when the users team is making any changes to the user service, they're going to make sure that they are responding in the way that they have agreed to within the contract. So there's a number of different ways you can do that. In Newsweaver, we use Pact. There's a few different frameworks, and I mean, some people roll their own thing, and that's perfectly okay. We really like Pact because it has kind of nice workflow, and it fits really well with our structure. Pact is not an implementation. Pact is a specification about what a contract between services looks like. It's human readable. It's going to be written in JSON with a set of interaction. I'll go into more details about what a pact looks like. So a pact and a contract is pretty much the same thing. So I might use the word for the 2 different things for the same thing. The philosophy behind Pact is very much the tolerant reader approach, that we want to evolve things in a kind of nice backward compatible manner. So we don't want to say if a provider, like the user service, for example, started to respond with more data, it's not really breaking the interaction because the consumer side should be saying, well, I didn't ask you for this field, but that's fine, I'm just going to ignore it. And it's nice because it gets us away from these kind of API versioning nightmares. So it's kind of just being additive with APIs works really well. And the philosophy of Pact is just don't break. We don't consider that the contract is broken in that case. And it comes with a number of implementation guidelines which the community has taken to basically implement a number of different clients, which would be for the consumer side or for the provider side, which is really nice when we go to something like microservices where we have a number of different technologies. And for example, you can have your consumer app that's written in Swift for an iOS app that's communicating with a backend written in Golang, and you can have a contract in between those 2 apps. And none of the apps actually have to care about what language the other side is written in, and they can issue a contract and the other side can verify it. Similarly, you can have an Angular app that's communicating with Ruby on Rails. It's really powerful for that that structure. So we mostly use the JVM stuff. If you're using the JVM, you can also use Spring Cloud contracts, which is like the Spring implementation of that kind of methodology. And Spring Cloud has also some compatibility with Pact as well. So we kind of use a mix of both. So let's look at it now from the work that these two teams need to do to come up with these contracts and verify them. So now we have our two teams working on their two separate services, and in this case, they're going to be working at their own pace in their own time, right? So the first thing we need to do is generate a contract. We need to generate that interaction that we're going to make sure that is validated and is not broken over time. So pretty much like any unit test that you would write for an HTTP consumer, we're going to start a mock server. Which is the Pact mock server, but it's pretty much like any mock server you would start inside your JVM runtime, for example. And the first thing we're going to do is define the interaction. So same thing, you write a consumer test, you're probably going to be saying to the mock, this is, if I send you a request like this, respond like that so that I can test that my code works. In the unit test of the consumer, we're going to call our business logic, which in turn is probably going to create an HTTP client, which is going to be interacting with our mock server, and we're going to make sure that the data we're getting back is fine. We're parsing it back into the entity we wanted. And so far, this is exactly what you would write if you wanted to unit test your REST consumer inside a service. But the nice thing now is when that interaction is triggered, we're going to generate a pact, which is essentially recording that interaction. We're just going to record everything that happened. So what is the request? What's the headers that were sent? What's the body of a post? And what's the response that we got? And we're going to record that in the pact. And now we can share this contract with the provider team, so with the users team, so that in their own time and as many times as they want, are going to be replaying that interaction and verifying that any time that they make a change, they're going to be able to say, is my API still responding in the way that my consumer was expecting me to? And that's very cool now because we can do all of this without even starting any special environment. This can be done on a dev machine. So there, any developer can just go and make a change and look in the pact, run the test, and on his or her own machine can verify that, okay, now the API change that I've made has actually broken the expectation from the other side. So it's a two-stage process. We play an interaction and we record it. And then the second stage is we replay and we verify. And we can just integrate that in our builds, which makes that very, very powerful. So let's have a quick dive at what a pact looks like. And I'm mostly talking about Pact, but Spring Cloud is very, very similar. And if you were to roll your own thing, a lot of people will do, it will look something very similar. And it's quite simple. It's human readable. What it will contain is information about who's the consumer and who's the provider, and a set of interactions that these two parties are agreeing on. One specific thing that needs to be looked at a little bit is the state that the consumer is expecting the provider to be in. Obviously, if we're going to make a request to say, well, when I interact with you to get a user called Pierre, then I kind of expect that, well, this user exists because otherwise that won't work. This is all in plain English, so we can just specify, well, I expect you to be in this state. That's going to help the provider to set up before we replay the interaction. Then it's going to specify the request. So very standard stuff, method, path headers. If you have a body for a post or a put, it's going to contain that as well. And the expected request that we want. So the status, same thing, headers, body, and might have some additional information about the body if we want to be more flexible. So rather than saying, let's say, name is, or if we have something like an email address in there, we don't have to make sure that it's the exact email address. If you tell me, actually, there's a body and there's an email address field that contains something that looks like an email address, I'm happy as well. It's nice to go that far because it's more flexible. We're not really kind of fighting about test data. So this is pretty much the output of the left side of the picture. So we play the interaction and then we record it. That gives us that contract. Now, what happens when we share that with the provider is we're going to need to verify that interaction is valid. So the users team is essentially going to start their full service. They don't have to mock anything. They're just going to be starting the full service. They're going to start either in memory database or their own like an instance of their database. And for each of the interactions in the contract, they're going to start by setting up the provider state. And that's at that point that they're going to be translating between that plain English statement saying, well, a user called Pierre exists, to now, for me, that means that I need to have a user in my database. And this is only at that point that we start making the transition to the implementation detail. The contract will never contain any SQL or anything like that, because the contract doesn't have to care about the tech behind it. It just says, this is what I assume you to be. Going to send a request, so we have all the details about the request we want to send. And it's going to hit the API and return with a response. And then finally what we want to do is we want to verify the response. So we look inside the contract, what was the expected one, and we're going to compare it. And that's at that stage that when we want to compare it, we want to make sure that all the fields are the same, or if they're compared by type or these kind of things. And the tolerant reader works here as well. So if the user service returned more data than necessary, then the pact will still be considered passing, because we don't want to be breaking these interactions. So it gives us a fair bit of flexibility on that. So there's one piece that's missing, though. We have those two phases, but how do we share things together? And let's say we have a number of teams that are maybe depending on each other for a number of different services. And I'll be honest, for the first year that we were working with contracts, we actually just were emailing each other files. It might seem a little bit crazy, but it got us going really well, and we got most of the rewards of it, as in we were able to just iron out very quick details, saying, oh, actually, yeah, this field has an S at the end of it, or you're actually not hitting the right endpoint, or just those kind of silly mistakes that otherwise we would have had to start full end-to-end environment mostly to figure out. Obviously, when the number of teams is scaling up, when the number of services is scaling up, when you have a number of different environments running, it's kind of difficult to sustain. So if you're using Pact, there's something called the Pact Broker, which is going to allow the teams to share packs together and version them and tag them and all these sorts of things that will basically allow this to be definitely more automated than sending emails. So all the teams that have consumers will generate their contracts as part of their build. At the end of their build, they're going to push the contract to the broker. And then the providers, whenever they want to verify that the contracts are still valid, they will go and ask the broker, say, well, can you give me all the contracts that are for my service? And then I'm going to verify that my changes are not breaking them. So it kind of just looks like a data store. So if you're using Spring Cloud, there's no broker, but what you use is just a plain Artifactory or Nexus, and you can just push a jar that has the contracts in it. So that gets the versioning and everything with it. But the broker also has a good few benefits, right? So first of all, since now we are pushing all the details about how our services are interacting, then we can actually start building relationship graphs and dependency graphs. We can see what our system looks like by saying, well, this service interacts with this one. And if we click on one of these arrows or one of these, one of these arrows in the graph, now we get the actual example of how those services are communicating with each other. We can list the interactions saying, well, this service talks to this one, and this is how it's talking to it. This is what kind of interactions that it's depending on. This is the way these guys are chatting to each other. And it's almost a free bonus there, because we are generating these contracts anyway. And anytime we push them to the broker, now our documentation is updated. It's not fully, like, let's say, Swagger API documentation where we have that kind of full spec. But we get it for free, as in now it's an example of how a consumer is using another service. And now when a new consumer comes along, a new team say, actually, I want to write a consumer for this service, they can go to the broker UI, look at any other consumer and say, well, that's how it works. That's the kind of request that I'm sending, and that's what kind of response that I can expect. So these are nice added benefits, but the core one is the fact that now we have versioning and tagging and like the REST API that backs all of this, so that now we can integrate all of this with our pipeline. So what does that look like in the pipeline? Because we want to automate this, right? The provider is going to implement, like the users team. They're going to implement their changes. So let's say they're changing the number of roles to be multiple. After implementing their changes in their build, they're going to get the packs from the broker, and they're going to be asking for, let's say, a couple of tags. So we want to say, give me all the consumers that I have that are in the European and US production environments. And from all the interactions that are there, we're going to be verifying that they work. And at this point, then already, before doing anything else, we can stop the introduction of that breaking change that would have only, we would have only seen in production before. Then the second stage is, well, there can be, let's say, a bit of a delay between the time where you have actually built something and it actually makes its way to the production environment. You might just mix it to like UAT or QA environments or these sorts of things. So just to make sure that we're not deploying anything incompatible, before we just the second before we go and deploy, we're going to just verify again, get me the environment that I'm deploying to. I'm going to replay and verify the interactions, and there we can also stop deployment of a provider that would have become incompatible in the meantime. And if everything goes well, then we go ahead and we deploy our service. And at that stage, we're actually confident that the changes we've made have not broken anything. The other side of the picture, the consumer side making their changes. If the login team or the authentication team makes any changes, they can generate their new packs as part of the build. They're pushing their packs to the broker, and then they tag their packs. But they're not tagging them with production yet because they're not in production. They can tag them with work in progress or dev or head or whatever you call whatever is in development mode. So that now we have a candidate for the next pact, because we don't want to generate a new contract saying, well, actually now we completely changed the way we interact with you, so you have to change all the ways. Before we go and deploy to the environment then, or even beforehand if we actually want to talk to the team directly, each of the providers that this service has needs to be making sure that, okay, the packs that we have, the new packs that we've generated, you need to verify that we're okay with them. You only need to do this if the packs have changed. So if the contract is the same, then you can skip that step, and most of the time that's going to be the case. So at that point, we can stop the deployment of a consumer that would be incompatible. And that kind of catches the problems where maybe you start interacting with the new endpoint and you have misunderstood the API. I would say this probably is only kind of 5-10% of the problems. The main problems is from the provider breaking the consumer more than this side. If everything is fine, we're going to deploy the service, and then at that point, we can tag it with production in Europe because we have deployed to production in Europe. And from this point on, when the providers are making changes, now they're using this tag with our new contract that has been agreed on because we know that was verified. So quick word of caution, which is not really a caution really, is one of the side effects of this is now people are going to start talking to each other, right? Especially when designing APIs. And it's kind of funny because at the beginning, like two years ago, when we started doing this, we were thinking, well, we need something to test our APIs. And the big side effect was, well, fair enough, we got the API testing bit, but we actually got people to talk to each other a lot more. Two teams that are going to be working on the service, it's going to become part of our vocabulary to just go, well, let's go get into a room or get to whiteboard and let's write down the pact. It's all human readable. We can handcraft it first and say, now we can all work on both our sides. And the provider team can verify that, well, the way they're implementing their API is working, and the consumer can do the same. And if at any stage of their development they're feeling that actually that's not right, then immediately they know that they can talk to each other because, well, if we do anything that's not agreed on our contract, then obviously we were going to run into problems. But okay, that looks all great. We've kind of gotten rid of the need for integration tests, but what's the catch in there? So I touched into this a little bit with the provider state, and the provider state setup for each interaction can become a little bit of a burden for the providers. Like, let's imagine a provider has 50 consumers. Every consumer for 20 interactions define a different state. That means a different SQL to insert data and all that. So obviously, there needs to be some communication. There needs to be some alignment of what the kind of states a provider can assume. It's not easy, but then again, if you have a service that might have 50 consumers, we'll start raising the case that maybe there's a bit of a smell here as well. Then, like any type of testing, if it just becomes a box ticking exercise, it's not going to work. You can't say limit everything to happy paths. So just saying, well, I have this interaction. If I get a user and the user is there, I'm getting this. What about the case where the user is not there? Should we actually write what happens? If I get a user that doesn't exist, do I get a 404? Do I get a 200 with no body? Do I get a 200 with a body that says user not found? What kind of body do I get? And maybe for all we know, the other team hasn't really thought of this. So by actually discussing it, we can say, well, actually, now we've tackled the case where that was not the so happy path. And we can put it in the contract. So now this is actually the way that's going to be rolling forward. And another team that comes along and say, actually, this is what it looks like when a user doesn't exist. And finally, the automation within the deployment pipeline, it's definitely not trivial work. So if you're starting on this kind of stuff today, emailing the contracts between each other, it's not a big deal. It just gets you going. It just gets you all the benefits of the collaboration and the communication and just coming together to say, well, this is what our interactions look like. And the reality of it is deployment pipelines are probably going to be different in every single company, if not in different departments. So you might have the different environment, different stages, different gates. So you kind of have to sit down and think, okay, what's the best place for me to run these tests? What's the best tags for me to use? At what stages should I just verify? At what stage should I replay? So take the time to think about it. But the nice thing is you don't have to think about it up front. You can just delay that until it makes more sense. So to sum up, after about 2 years, a little bit more than 2 years of consumer-driven contracts, but what we've seen is definitely the big plus is now we're much more confident when we're making a change to a service, when we're coding, and especially, and finally, when we're deploying that service. When we've almost gone away from, we're pretty much gone away from full end-to-end environments, from integration tests that take ages to run, that take ages to start, that are unstable, that we run those 30 minutes of test suites that fail, and then we have to run them again, and then the third time it passes us that, yeah, we took an hour and a half to deploy a change that actually didn't really need any, like, all that setup. The collaboration is one thing that we hadn't foreseen, but is actually one of the main upsides of this is even if you're not using the broker or if you're not using this in your pipeline, having that collaboration around the API design, it's invaluable at that stage. And the fact that it's consumer-driven means that now when we're going to design new endpoints, a new API, the APIs are designed with the consumer in mind rather than the providers just going, yeah, here's my API, this is how you should use it, and washing my hands off it. Then the consumer side just goes to implement something, said, well, your API is fine, but I need to call it 50 times to get what I wanted. If we had just flipped that around a little bit more, it would have been definitely more efficient. So that collaboration now starts with designing that interaction up front. And finally, that leaving API documentation as well is something that we didn't really think of. And we had some headaches about saying, well, will we use Swagger to document our APIs? And then sometimes, depending on your language or your frameworks, then it just turns into like more annotations than code. And if you're doing it yourself, then is it going to be out of date? Not saying Swagger is not good. Swagger is really good, but it's more work. That leaving API documentation, by example, is almost for free there. So try it out. It's very easy to set up. Pact.io and the Pact Foundation on GitHub. Spring Cloud contract was set for JVM, but has support for understanding the contracts generated with Pact. And if you're interested in diving into the more details, definitely recommend reading the Pact metrics by Beth Scurry. So Beth is one of the original creators of Pact, and she's explaining essentially the thinking behind the tagging of the different environments and when to verify what, to just make sure that when we want to verify that consumers and providers are backward or forward compatible. And a few other blog posts on how would you get started with this and how you can actually start up with a broker pretty easily. So that's me for today. Hopefully you learned stuff and that gave you some interest of starting that on your own project. You can start small, start with a couple of services, and I promise you'll see the benefits very, very quickly. So thanks very much.